Welcome to Algebra Online. Here we have a video where we're going to show you how to find the determinant of a 3x3 matrix in 3 different ways. There's actually more than 3 different ways, and we'll touch upon that later in some later videos, but here we'll show you some interesting facts about taking the determinant of a 3x3 matrix. First of all, we'll take the method that we've already seen several times during this video series here. You can say here that the determinant of A is equal to this first top left element, minus 1, multiplied times the determinant of these 4 elements, minus 1, minus 2, and 3, minus the middle element up here, minus 1, times the determinant of these 4 elements, which is 1, 0, minus 2, and 3. And then we get plus 5, the third element up there, times the determinant of these 4 elements, which is 1, minus 1, 0, and minus 2. When we work those out, we get the following. We get minus 1 multiplied times negative 1 times 3 is minus 3, minus negative 2 times negative 2, which is positive 4, minus 3, minus 4 is minus 7. Minus times the minus is plus 1 time. And here we get 1 times 3 minus 0, which is 3. And here we get plus 5 times minus 2 minus 0, that gives us minus 2. Combining these, we get 7 plus 3, so this gives us 7 plus 3 minus 10, which is 0. That's interesting, but that's the result of that 0 of that matrix. So determinant of A is equal to 0, which also means that we cannot find the inverse of that matrix. It's invertible. It's non-invertible, I should say. Not invertible, but non-invertible as we call it. The second method is kind of an interesting method. Instead of going across the top row and using each of those elements and then multiplying that times the determinant of the remaining elements that are not crossed out, we can go this direction. We can say that the determinant of A is equal to, again, we take the top left here, minus 1 times the determinant of the remaining elements here when we cross out that row in this column. So we get minus 1, minus 2, and 3. That's exactly the same as what we had up here. But now instead of going to the right, we're going to go down. So that would be minus this element 1, because we alternate the signs, plus, minus, plus. And if we cross out this row and this column, we have those 4 elements right here. We get minus 1, 5, minus 2, and 3. And then we come down here, that would be plus, I'll just write it in, 0 times, and just so we know how that works, we cross out this row and this column, we have those 4 elements up here, that would be minus 1, 5, minus 1, and minus 2. And we will get the exact same answer, of course, providing we don't make any mistakes. Let's go ahead and do that. We have minus 1, and of course that will be the same as the minus 7 as before. Now we have, instead of plus 1, here we have a minus 1 times the product here, that's minus 3, minus a minus 10, that's plus 10 minus 3, which gives us 7. And then here we get plus 0 times, I'll just work it out, that would be a positive 2 minus a minus 5, that would be a positive 5, so 2 plus 5 is 7. Of course, 0 times 7 is still 0. And here we get a positive 7, a minus 7, and a plus 0, which is equal to 0. Notice we got the exact same result. The determinant of that matrix is equal to 0, no matter if we take those rows right here and then the remaining 4 elements when we take the determinant of those, or we can go down this row. Actually, we can also go down this row, or we can go down this column. And again, we get the same result, and we'll show you some examples of that later. But another technique, in this case, the third technique we're going to show you, is to repeat this matrix here, write down all the elements. So we end up with minus 1, 5, 1, minus 1, minus 2, 0, minus 2, and a positive 3. Next, what we're going to do is we're going to repeat the first 2 columns and write them to the right here. Again, so we have minus 1, 1, and 0, and a minus 1, a minus 1, and a minus 2. What we're going to do now is we're going to multiply diagonals, starting with the upper left here. We're going to multiply, and let me use a different color. So we're going to multiply this diagonal here, we're going to multiply this diagonal here, and we're going to multiply this diagonal here. And now subtract, when we go the other direction, use a different color, we're going to multiply this diagonal, and this diagonal. So we're going to add up the products of those three diagonals and subtract the product of these three diagonals. So that's how that works. Starting with the first diagonal, we have minus 1 times minus 1 times 3, that's 3. So this is equal to the determinant of this thing right here would be equal to, we get 3. The second diagonal is minus 1 times minus 2 times 0, which is plus 0. The third diagonal, we have 5 times 1 times negative 2, that's a minus 10. Subtract from that the product of these diagonals. So here we have 5 times the negative 1 times 0, which is 0. Here we have a minus 1 times a minus 2, which is a positive 2, times a minus 2, which is a negative 4. In the last diagonal, we have a minus 1 times a 1, which is a minus 1, times 3, which is a minus 3. Simplifying that, let's see what we get. So we have a 3 minus 10, that's a minus 7, minus what's inside the brackets, which is a minus 7, which gives us a minus 7 plus 7, which gives us, again, a 0. So either way you want to find the determinant of a matrix, notice you can take the top row and then work out the determinants of the remaining 4 elements. When you cross out, you take this element right here, you cross out this row and this column, you end up with those 4 elements. You take the determinant of that. You take the second element here, you cross out this row and this column, you take those 4 elements. The third element here, you cross out this row and this column, you take the next 4, or you can go down the side here. Minus 1 times the determinant of those 4, this one times the determinant of those 4, and this one times the determinant of those 4, and you can go down the bottom or down the right side, it doesn't matter. You'll get the same result every single time, and that's how it's done.